Before we get to all the cool parts of this video, we have to first go over the PDS, or the product design specifications. Now, instead of reading out all these things and boring you, I'm just going to hit the most important ones. FR01, 04, 06, 07, PA01, SE01, and SE02. For the functional requirements, these are the main ones. Is the device compatible with a half-inch CCV? Yes, it is. Does the flow meter detect in a range of 0.5 milliliters per minute? Yes, it does. Does the encoder provide precise angle measurement to 0.5 degrees? Yes, it does. Does the protractor allow the user to read the measurements to 0.5 degrees? Yes, it does. Next up are the packaging and service requirements. Does the device use non-corrosive materials that can withstand the flow of water? Yes, it's primarily made of stainless steel. Does the device operate properly at room temperature? Yes, it does. Does the device handle pressure up to 50 psi? Yes, with a safety factor of 2, up to 100 psi. Now to go over how the device actually functions. Assuming we've assembled the pieces, the water will start flowing through the quick connect with a bypass valve to alleviate excess pressure. In the photo shown, the bypass valve is built into the system instead of the prototype. Here's a video of us screwing in the bypass valve we built from Home Depot parts when we were testing it over the weekend. Next, the water then flows through the water filter, into the flow meter, and then finally into the valve. The sub-assembly is driven by the GRC X24 MFT actuator through the Belimo tappet into a 5-to-1 gear reducer, which is then keyed into a collet shaft through the encoder, which turns the valve and the collet housing, showing the angle on the protractor properly. This channel sucks, dude. Why is there nothing good on? Wait. Why am I in the video?
I see the time. It's 11:33. We're at Texas Chicken, but it does not matter. I have a valve, and I can't test it, and it causes me great pain. You, sir, do you have a solution to that?
No, I don't.
Exactly. I know you went everywhere. You checked Home Depot. You checked Lowe's. But what did you find? Nothing. What if I told you I have a solution? You want your valve tested, and I got the perfect magic wand for that. Here at Belimo, we are introducing our new Belimo valve tester, certified to work with all 1/2 inch valves. Including my valve? Yes, even your valve. Is it 1/2 inch?
It's 2.5 inches.
No, sir. Please, get out. Your valve is not being tested here. Now, what if I told you, instead of paying $10,000, you can do a solid deal of $9,999.99. Include that. Alright? Perfect deal. So much better than our competitors for you, the consumer. And even he agrees. He will gladly pay for our valve tester. Come check it out. Only at Belimo. Even the cops want it bad.
So you want to build a testing rig for a 2 to 3-way characteristic Belimo control valve, huh? Before that, there's a couple things you need to do. First off, you need to actually design the entire thing, potentially taking months, multiple iterations, scope changes, many energy drinks, and sleepless nights. Got that? Good. Then you have to code everything, including the flow meter, actuator, and encoder. I don't have footage of that because it's typing on a computer. You're just gonna have to imagine it. Next up, you actually gotta build it with very precise tools such as backwards pliers, hammers, 4 sleep-deprived mech students, and more. Once that's done, then we can finally drive all the way up to Connecticut to the Belimo lab to actually assemble and test the prototype. Once inside the testing lab, we can see where we're set to assemble the prototype and get to work. First, we attach the water filter to the system, making sure that no pesky particles get into our expensive flow meter. Then, we screw the flow meter into the system and support it from below so that the piping doesn't bend or snap. Next, we hook up the flow meter to our extremely well-wired electronic systems. Attach the sub-assembly and get ready to test.
Thing is, I am. I'm zooming in right on it.
Do not zoom into it.
This is what happens when you let a mechanical do wiring.
Now that we've showcased our extremely sophisticated system, it's ready to start testing. First, we want to make sure that the actuator is actually turning the shaft, allowing us to measure the angle on the protractor. After that, we start the water flow and run our LabVIEW code. When the flow meter detects the flow, the valve's angle is marked down and the critical angle test is completed. With that, the prototype testing is finished. After we replace the 2 carbon-infused PLA parts with aluminum machined ones, the prototype will be fully finished and be ready to put to use, instead of just being tested. Luckily, we were able to secure replacement parts for the plastic pieces of the shaft, which were twisting instead of transferring the torque to the valve and opening it. we took a trip to Home Depot and then drove to Franklin's house to do some testing with the new parts in his garage.
Type.
So this is mine. Already got the screwdriver. Oh, cause like we're taking out wires and shit.
After a couple days at the garage working on fixing some code issues and sticker problems, we finally got the entire thing to work, shown in this footage. Thanks for watching, and I hope that this project is satisfactory.